Now we just talked about exportation. We went ahead and ran our job here, moved the signing certificate to a data set. When you export root certificates, you use the cert format as I mentioned before. Exporting personal certificates, you would use the format of PKCS12. This format is recognized most everywhere. You'd use binary mode in your file transfer, and also be aware that private key content is included. And by the way, we will run a job a little bit later exporting a personal certificate, and you'll notice in that job that I include a password with the job, because once the certificate is used on the remote platform that it might be transferred to, it should be protected with a password so that only parties that have a need to know can open up the certificate upon receipt. So now we'll run a job to create a personal certificate. Let's take a look at that. We'll go back here. And this is that JCL. This is SSL create personal certificate job E. Basically looks the same. Let's assume we're creating and signing this personal certificate on the Z platform so that we can later export it to a data set and then FTP it in binary mode to the client platform that will eventually end up using it. So when this job SSL create personal certificate runs, it assigns a distinguished name of client A1 and then all these other distinguished name fields to the certificate. Further down we see it gets its window of validity, May 28th, 2012 through May 28th, 2013, which is pretty typical to make these good for about a year. And then we have a label name assigned to the certificate, all lowercase, because this is what distributed platforms will expect of IBM WebSphere MQ Unix. And then very important, we indicate what we're going to sign this personal certificate with. We're going to sign it with CertAuth label A root cert, which is the certificate we created in the previous steps. And it's important to know that once this certificate arrives from the remote platform back to ZOS, if that's the configuration you're using, ZOS will have to have this certificate in its queuing in order to be able to authenticate this private certificate or personal certificate that's been created. So let's go ahead and submit this one to create our personal certificate. And I think this was job B. And that ran well. We'll go ahead now, and condition code 0 again. We'll go ahead now and we'll connect this certificate to the keyring just because. We don't have to, but we're doing it just to show that we can, but it's not necessarily a requirement. So when you take a look at this job, you'll see that connecting the certificate will be done by its label. It'll be done to the keyring. It'll say now, instead of a usage of CertAuth, it has a usage of personal. With the same authority, the rack decert commands are being issued under MQM task. And so we'll run that. Let's do a submit here. Actually, let me take a quick look at it one more time. I just want to grab out the rack decert command that we're going to issue manually after this runs. So we'll submit this. This must be job F. And when we back out to our command panels, we now see that not only do we have our signing certificate, which just signed this personal certificate in our keyring, we now also have as a default yes certificate our IBM WebSphere MQ Unix personal certificate. And so our keyring is building up nicely. As an aside, I did want to mention, depending on where your certificates are located, your certificates will have different file types on Windows. For PKCS12 certificate, which this certificate would end up being, because it includes a private key. You will have an extension on it of .p12. If we were using the cert signed certificate, which is a format of cert binary 64, this would have a file extension on Windows of .cer. On Unix, it would have a file extension of .arm. So if it became necessary to move the certificate to those platforms, those might be the extensions you would have to put in place. On the Z platform, the cert binary 64 exported certificate would have a low-level qualifier of .arm, which we saw. And then if it was a certificate with a private key in it of format PKCS, that would have a low-level qualifier of .der. Okay, so moving on. Just as general information, we wanted to distinguish between what the effects of RAC DCert GenCert or RAC DCert Connect were. Well, RAC DCert GenCert or RAC DCert Add can be used to add certificates to a RACF database. But one of the differences with RAC DCert GenCert is that the GenCert, in addition to adding a certificate to the keyring, can also be used to create a public-private key pair for SSL protection. Services such as VeriSign or Thought use similar processes such as CSR or certificate signing requests in order to provide users with certificates which have been validated by those third parties. So one of the main reasons we're using RACF here to do these illustrations is because it won't cost us $1,000 to give the basic idea of how SSL is implemented to the user or to the viewer. RAC DCert Connect, on the other hand, stores the certificate into the keyring. So these are really two different things. One makes the certificate known to the RACF database, whereas the other actually places it into the keyring. So you can have one without the other, and things will not work as expected, but both can be done independently. We'll discuss expiring certificates in just a minute, but first let's take a look at exporting that certificate that we just connected to the keyring. We'll go back to our womack.work JCL, find SSL, and then we have a job called export personal certificate. This JCL is written again to export IBM Webster MQ Unix. This is our G job. I believe this is the very last job we're going to run. It'll write it out to a data set called tapper.womacux.dir. And once again, we said we use the .dir format for PKCS 12 format certificates. These contents, once they're moved to that data set here, can be FTP'd in binary mode, and given the password, can be opened by the receiving platform. In this case, the password that was associated with the certificate was IBM. So we'll just run this, but before I do that, let me grab my data set name again, and we do a submit, and we type G. And by the way, that character doesn't have to be G, but it just keeps things in order. I back up, I take a look at my data set, and sure enough, there it exists. I look at my information, it shows that I created it today, very similar to the signing certificate export data set. When I browse it, it's utterly unreadable, but that's as it should be because it does contain a private key. Okay, let's discuss certificate renewal now. Certificates always eventually expire. The personal certificate that I had in the keyring had a time window of only a year. When it comes to updating certificates which have already expired, for instance overnight, this can be disruptive to business operations. To avoid this, many IBM Tech Notes recommend proactive renewals of certificates which may be about to expire. Now, the job you're looking at here was pulled from Tech Note 1248143, which provides this sample JCL in order to allow the user to check an unloaded copy of the RACF database. You can unload the RACF database by running a utility called IRR DBU 00. That will list all of your certificates in order of expiration once this job is run, so that you can determine which ones need to get action done upon them first. Now for MQ series, while you can create new certificates using the existing label name, if doing so, you should always recycle the Webster MQ channel initiator on ZOS, since MQ has no mechanism to determine or differentiate between certificates based solely on the label name. So as renewal goes, there are several methods to renew certificates, and you're best to use the method most accommodating to your business. If using RACF, you may choose to use the rekey and rollover methods documented in the RACF command language reference, if that's best for your environment. I did want to show what references we recommend you take a look at. There's a good red book, the Webster MQ Security in an Enterprise Environment. I use on a fairly frequent basis the RACF command language reference, because that documents everything you need to know about all the RAC decert commands. And then there's some great diagnostic information that can be found in the System SSL Programming book at the bottom there. And the SSL Programming Guide and reference provide further backup to that information. So I'd like to thank you for watching this video. I hope you found it useful, and as always, if any problems involving SSL do occur, feel free to contact the Level 2 Support Center, and we'll be glad to help work through the issue. Thanks a lot, and have a good day.